You will be doing a complete project on foundation design of a building. In this first video, you will be understanding the problem statement of the footing design project. You are going to design a mat footing for a building. You will use the parameters obtained from the tall building, designed in our course on tall building design. The process of analyzing the loads acting on the footing, and thus arriving at the problem statement, is being illustrated. The students who have not done the course on tall building design, the problem statement will be explained in its completeness, separately. Just proceed with the initial part of this video, and you will arrive at the problem statement. For those of you who have done the final project on tall buildings, open the project in the eTabs software. Open the file of the final project in eTabs. Once the file is opened, go to the Model Explorer and locate the Analysis option. Please note, the Analysis option might not be displayed if your model is unlocked. In that case, run Analysis on the building model again. Expand the Analysis option, and then Results option. Then under Frame Results, double-click on the Column Forces option. A table is displayed, listing the axial forces and moments through each column. You need the forces applied on the bottommost story. So right-click on the heading, Story, and select Story 1, to filter the results of Story 1. Now in Story 1, the loads and moments for different load patterns and combinations are displayed. Right-click on the Load Case/Combination option, and select the dead load, then click on the heading, to filter out the dead load results. For each column, there are 3 values displayed. These values are at different locations of the column. You need the loads at the bottom point, that is at 0 meters. So right-click on the Station option and choose Sort Ascending. The axial load values, at 0 meters distance of each column, will be displayed at the top. And accordingly, the axial force for the dead load are displayed. Stretch the table upwards to view all the results. Thus you will get the dead loads, and the live loads can also be checked by changing the option. First we'll check the dead loads, so change the Load Case option to Dead. Now the columns are named as C1, C2, C3, etc. So how do you know which column is named what? In the Model Explorer, click on the Detailing tab. The Detailing tab is empty, so go to the Detailing menu, and click on Start Detailing. Once detailing is complete, expand the options as shown, and select the Concrete Column Layout Story 1 option. The resulting plan shown in the software displays the name of each column. Thus the column at the bottom right is C1, and as you go up, the columns are C2, C3, C4. Similarly for the next row, the bottom column is C5, and they are numbered serially in the same way, up to the 16th column, C16. In this way you can find the dead and live load through each column at station 0 meters. Now how do you know the dimension of each of these columns? In the Model Explorer, select the Model tab. Expand the Structural Objects option, and go to Story 1. Expand the Columns option, and each of the columns, from C1 to C16 are listed. Double-click on each column, to find the dimensions. C1 is a 500 by 500 millimeters dimension. Similarly, C2, C3, C4, C5 columns are of 500 by 500 millimeters dimension. Again, C6 and C7 are of 600 by 600 millimeters dimension. After checking all the columns, it has been found that the 16 columns are of two different dimensions, 500 by 500 millimeters and 600 by 600 millimeters. All the dimensions are being listed ahead. Also, you need to know the materials in these columns. Go to Define, Section Properties, and click on Frame Sections. Select the C500 by 500 column, and click on Modify/Show Property. The material is M40, and the rebar is HYSD500. The C600 by 600 column also has the same materials. So based on the information gathered from here, we will arrive at the problem statement, which will be explained now. This is the plan of the building, for which you have to design a mat footing. There are 16 columns in total, which are arranged 6 meters apart, in both X and Y. As explained, the column names C1, C2, C3, etc. are shown, up to C16. You have to consider a safe bearing capacity of 300 kilonewtons per meter square, and an allowable settlement of 1 centimeter. The data obtained from the building project in E-tabs is being displayed in the table. The column name, along with the dimensions, the dead and live loads through each of them, and the materials, are being displayed. Please note that C6, C7, C10, and C11 columns have a dimension of 600 by 600. Keep a note of this data, as you will be needing it to design the footing in safe. The SBC of the soil in this case is 300 kilonewtons per meter square. Hence the subgrade modulus is 3 times 10 to the power 4. The base slab of the building is 18 meters, in both X and Y. So considering 18 meters length, the design strip width is 4.5 meters. But the thing is, there is no concrete provision for the strip width, and you can allow a lesser width. In this project, we will take a strip width of 4 meters. Now the plan shown is the plan of the building. The mat footing underneath will be extended on all sides to cover the corner columns. Let us design a footing, which is extended 2 meters on all sides of the building plan. Then the actual length and breadth of the mat footing will be 22 meters. You will now start the project in the SAFE software, which you will learn in the next video. Thanks for watching.